In this video, I'll be working through the question you see on the screen here from the Maths Paper 1-3 from 2024 Cambridge A-Level exams. If you're looking for a different question from this paper, have a look in the description below. There should be a link to a playlist. And if you're looking for a different paper entirely, have a search on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to doing in the classroom. But remember, we're not in the classroom, we're on YouTube, so take advantage of that. Pause, rewind, even watch it at a different speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks.
In question 11, we're given this function here and we're asked to find the range of it by completing the square. So let's do that. Let's complete the square of this side here. That's really, we're taking this quadratic. Let's write it again a more common way. Minus x squared plus 6x plus 10. When you're completing the square, you don't have to do this, but I would advise just change this number to a 1 whenever you can. In this case, it means taking minus 1 outside. So we'll deal with this later on, and we'll just work from this. If we take a minus 1 out of this, we get x squared. If we take minus 1 out of a 6x, we get minus 6x. Take minus 1 out of 10, we get minus 10. So we're going to complete the square of this part now. So how do we do that? Let me just stay right in here. We get x squared minus 6x, and I'm going to leave a space here for two numbers. It's going to be two numbers here. How we complete the square is we make up a new number here that this will be a perfect square. And then this number will combine with this one to get back to minus 10, because we're not really allowed to change anything. Hopefully that'll become clear on the next line. X plus or minus something squared, and a number here. So we're looking for something that will go here, that when squared it will look like these three numbers. And it's actually quite easy to get in that it's just half of this number. It's just minus 3. And that hopefully is clear, because if we square this two brackets out, it's x by x, x squared. It's minus 3 by x, minus 3x, and x by minus 3, another minus 3x for minus 6x. Two of them. That's where dividing this by 2 came in. And the number that would have to be here to make this make sense would be minus 3 squared, which is plus 9. So I just put plus 9 there. I cheat. I just make up plus 9. But what makes it not cheating is I put another number here. So these two combine to be minus 10. So that's minus 19. And these three become here. Minus 19 is here. That's what completing the square looks like. You can leave it like this, or you can multiply minus 1 back in, and we get minus, outside this bracket, minus x minus 3 squared, plus 19. And remember, this is fx still. This is some function fx. Now, how does that help us tell you the range? So you can get the range just by looking at this now. But I'll draw a few pictures just to make it clearer. Here's something squared. And we know something squared looks like this. But it's minus something squared. So we know that looks like this. It's offset. It's x minus 3 something squared. So we can start getting a bit more exact with that one. Let's see, we'll put it up here. It's when x is 3, this is 0. So when x is 3, this is 0, and it looks like this shape here. That's what this looks like. But then we add 19 to it. So everything moves up 19. We'll do it one last time. And 3, 19, and it goes something like this. That's what this function looks like. So when they asked us the range, what that means is how big can this get and how small can it get? What's the biggest, and we're talking about the y-axis here, the fx axis. What's the biggest number possible? And that's 19. What's the smallest number possible? And it goes on forever down. So it's minus infinity. So you'd write something like this. Fx has to be less than or equal to 19 and bigger than minus infinity. That's full marks to this question. Be careful, you need an equals here. it could in fact hit 19. So you need to have that equals. If you put equals here, it's wrong, because we can never equal minus infinity, but I don't think you would lose a mark. But I would advise not to do it. You don't have to write this. This is just the same as less than or equal to 19. We assume minus infinity, or in fact you can write it like this, minus infinity to 19, and you do need to put in this square bracket though to make that make sense. Again, if you had a square bracket here, I don't think you'd lose a mark, but maybe you would. Okay, that's it for part A. Okay, for part B, they introduce a new function, this gx here, but it's missing some information, this k. But they give us more information. They tell us there's two curves that hit each other. And one of the curves is y is equal, and it's complex looking, the inverse of g of f of x. That's one of the curves. And the other curve is just the gx. Y is equal gx. These two curves, they hit each other, and they tell us they only hit each other once. That's going to be very important later on in the question. They only hit each other once. Your first goal should be, what does this look like? And we already know what this looks like. This one looks like 4x plus k. So what does this one look like? That's your main goal. That's where you're getting a few of your marks here. To do that, we need to know what the inverse of g looks like. So that's really now your first question. What's the inverse of g look like? To get that, how I do it is, I think of y here, y equals this, and then I switch to x and y. So I get from here, instead of y on this side, I put x. Instead of x here, I put y plus k. Yeah, some people do this the other way. They leave y and they leave x, and they do what I'm about to do, and then they switch x and y. Either way, you have to switch x and y somewhere. Rearrange this. K comes over, x minus k equals 4y. Y is equal, divide both sides by 4. X minus k over 4. That is the inverse. That's g. The inverse of g of x is this function here. Now, this isn't just the inverse of g. So this function here, this one is y is equal the inverse of g, and that tells me it's something. Let's leave a big bracket here. Minus k over 4. The inverse of g is the something. If I add an extra bracket here, I think it makes more sense. The something minus k over 4. The something in this case is fx. So what goes in here? Fx goes in here. You could use this one or the completed square one. It doesn't matter. Although this one just is going to save me one line later on. So I'm putting this in here. This is 10 plus 6x minus x squared. That's this curve here. We can make this a little neat. No, I'll leave it like this. Actually, there's no point making it here. That's this curve, and y equals this curve as well. And we know they hit each other. That means this y and this y equal each other at some stage. When they, I don't know what these curves look like, but we know they hit each other, and they hit each other only once. That means this y and this y must equal each other. So let's put them equal each other. That means putting this equal to this. Let me just put it here. 4x plus k. Multiply both sides by 4. That becomes 16. That becomes 4k. We can add k to both sides. That's gone. That'll become 5k. Let me clean up then the next line. This side will be minus x squared plus 6x. Oh, sorry, and this we have minus 16x could come over here. Sorry, so we'll say minus 10x. That's this coming over, and we'll have a 10 here, plus 10, and we could have minus 5k here equals 0. Sorry, I did that a bit fast because I was running out of room. But that's a quadratic. I change all the signs, I guess. I don't know why I didn't do this. Plus 10x minus 10 plus 5k equals 0. Let me just double check that is what I had. Yeah. So that's a quadratic we find when these two curves hit each other But we can't solve this. There's two unknowns. There's x, which we're used to, but there's a k. So we need one more bit of information, and what that is that they only hit each other once. Quadratics give us two answers, except when, let's see, when the b squared part, the b part, minus 4 times the a part, that's 1 in this case, times the c part equals 0. When this happens, there's only one answer to this. Let me rub off up here and I will squeeze the answer in. So I'm going to write this again, but instead of b, I'm putting in 10. So 10 squared is 100. Minus 4, instead of a, I'm putting in the 1. That's in front of this x squared. Instead of c, I'm putting in the non-x part. That's minus 10 plus 5k. And I know that equals 0. I can solve this. Let's see, get all the k's out. We'll have minus 4 times 5k, that's minus 20k. All the numbers, let's move them over the other side. This guy will be minus 100. This will be plus 40 moved over, that's minus 40. And that'll be k, all the minuses cancel. That'll be k is equal 140 divided by 20. K is equal to 7. Be careful, that's not your full answer. You still want to know what x and y is. I guess I'm going to need more room. Let me clean over here and I think I can fit everything in. So the question was find the coordinates. That means find the x, this x here, the answer to this equation, and the y. Have I left myself a y equation? Yeah, up here, thankfully. Okay, so knowing k is equal 7, let's write this equation again. This is x squared plus 10x. That's 35 minus 10. That's plus 25 equals 0. This is a quadratic. It should be a very easy quadratic to solve because we know there's only one answer. We know this is a perfect square. So that means the square root of 25 is one of the factors. That's x plus 5 squared. And that works. 5 times x times 5 is 10x. This equals 0. That means x must equal minus 5 is the solution. Again, they want a coordinate. So minus 5, we need the y part. It should be two options. This was one of the options and y equals this was one of the options, or up here. So we also know y must have equaled 4x plus k. Remember, that's I think this part probably fooled a few students. Wait, where was the y again? So y is equal 4. We know what x is. X is minus 5. We know what k is. That's plus 7. That's 20 plus minus 20 plus 7. It's minus 13. That's your full marks. Well, I always like to write it in a coordinate form to give to the examiner. This is your final coordinate for part B. Okay, that's it for question 11 and that's it for the entire paper. If you have any follow-up questions for this question or for anything in the paper, let me know in the comments below. I'll do my best to get back to you. Thanks for watching and have a great day.